Okay, now we're going to do a little bit of day two. Day two had everything to do with taking these inverse functions and kind of nesting them, if you will. What I want you to understand is this. There's a couple things you need to remember, and what I talked about in class is this exercise or this practice really boils down to if you know two things. The first thing is if you remember about your right triangles, the following. When you have a right triangle, you have the hypotenuse, you have the opposite side, and you have the adjacent side. It's all from the perspective of this angle, and we're going to draw a triangle that looks like this. So the first thing to remember is the Pythagorean theorem. And the Pythagorean theorem is when you take the opposite squared plus the adjacent squared, you're always going to get the hypotenuse squared. That's the first thing. And the next thing you're going to need to remember is you're going to need to remember your Sohcahtoa stuff. And the really nice thing about the Sohcahtoa stuff is that unit circle I gave you for day one at the bottom, it has all of them. And really what I'm going to look at is I'm going to look at these ones, the first ones. I know we actually did the Y's and the R's, but I'm going to look at these first ones. Sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse. Tangent's opposite over adjacent. And cosecant hypotenuse over opposite, reciprocal. Secant hypotenuse over adjacent, reciprocal cosine, cotangent adjacent over hypotenuse, reciprocal tangent. So it's going to be knowing that, because here's what we're going to do. This really nice thing about the inverse functions is as follows. If I go ahead and I take the sine of the arcsine of, say, pi over 3, inverse functions cancel each other out. They go away. So what happens is this cancels that out, and I'm left with pi over 3. So when I deal with these things, it's really nice that if I can take an inverse, I can kind of get rid of the trig. So if I was taking the arctangent of the tangent of 7, the arctangent cancels out the tangent, and I'm left with 7. So those are really nice. So if I get a problem like these ones down here at the bottom, 37 to 42 that we did in class, it's really nice. All of them just cancel each other out. Secant of the arcsecant is going to equal 2. They cancel each other out. Cosecant of the arccosecant is going to equal root 2. They cancel each other out. So those are the easier ones. Now I want to show you how we do a little bit more challenging ones, the ones where we have two different trig functions mixed together. And I didn't share my screen, so we're going to go back and share my screen. So let me do a quick review. So here is the deal. We're talking Pythagorean theorem. Opposite squared plus adjacent squared equals hypotenuse squared. So we're looking at this triangle right here. It's going to be justified like this. You'll get used to drawing it like this. We're going to use Sohcahtoa. And what I had said was all the Sohcahtoa stuff you need to know is down here at the bottom of the unit circle I gave you. And then what I talked about is I talked about how when you use inverse functions with the trig functions, they cancel each other out. So that's what makes those go away. So sine of the arcsine cancel each other out. You're left with pi over 3. And so now what I want to do is I want to show you what happens when I'm given a function where it's two different things. So the way I'm going to do is I'm going to start in here. And the way I'm going to start in here is as follows. I'm going to draw myself a right triangle. Okay. And the right triangle is always going to kind of be justified like this. I'm going to go sig theta, and we're going to put it here. And now, when I look at this, our cosine is adjacent over hypotenuse. So what that tells me is I'm given the adjacent side, which is 3. That's the adjacent side. I'm given the hypotenuse, which is 4. Now what I can do is I can figure out this opposite side, which I don't know. I use the Pythagorean theorem. The Pythagorean theorem is opposite squared plus adjacent squared equals hypotenuse squared. Plug in the numbers I got. So I don't have opposite. So we got opposite squared plus adjacent, which is 3 squared, equals 4 squared. That's going to give me opposite squared plus 9 equals 16. Solve for opposite. I'm going to subtract 9 from both sides. I'm going to get opposite squared equals 7. I'm going to take the square root of both sides, and I'm going to find out that this length is root 7. So now I've figured out all 3 sides. Now I can go back to my original problem. My original problem, I've used everything in here, so I can kind of get rid of that. I don't need to worry about that anymore. Now I just need to worry about what is tangent of an angle. And if we go back and we look at our unit circle, tangent of an angle is opposite over adjacent. Tangent is opposite over adjacent. So what I am going to do is I'm going to take the opposite side, which is √7 that I just calculated. I'm going to put it over the adjacent side, which is 3. The answer to this problem is √7 over 3. So what this whole process is, in its simplest terms, you're going to use the thing on the inside to draw a right triangle, label the two pieces you got. Use the Pythagorean theorem to solve for the piece that's missing. Then go back to the original problem, look at whatever trig functions on the outside, use Sohcahtoa to figure out which pieces you're going to use. So let me do this one. Cosine of the arctangent of -2. First thing I'm going to do is I'm going to make that a fraction. Everything is a fraction. You just put it over 1 if it's not immediately clear. I draw myself my triangle. Theta is always going to be in that bottom left corner. Tangent is opposite over adjacent. So that tells me the opposite side is going to be -2, but if you think about it, you can't have a negative measure of a triangle. So what we're going to do is just call it 2, and the adjacent's 1. And now what I'm going to do is use the Pythagorean theorem again. In this case, opposite squared plus adjacent squared equals hypotenuse squared. Hypotenuse is what I don't know. So that's 2 squared plus 1 squared equals hypotenuse squared. That's 4 plus 1 equals hypotenuse squared. That's hypotenuse squared equals 5. Square root of both sides. The hypotenuse is going to equal square root of 5. So it's just a square root of 5. Now I go back up. I've used this in the middle. I look at what is cosine of an angle. Cosine of an angle is adjacent over hypotenuse. In this case, the adjacent side is 1. The hypotenuse is √5. So that's what we did on day 2. We actually worked on the back side of the sheet, and we worked through all of these problems, which all follow the same process. 25 through 36 were ones where you had to draw the triangles and solve. Problems 37 to 42, we were able to just go right to the answer. So that's what we covered on day 2.